What's up, everybody? Welcome back to yet another episode of Basic Chem 101 with SIHLE BONANI. My name is SIHLE BONANI. We are just coming back from a very long break. I hope everyone is refreshed and we are keeping safe. So today we are doing chemical formulas.
Let's go. This is how every child that wants to make it one day. Zimbo say class and brothers of mine is elsewhere. Bring out Uzuzani, I've not moved it that day. Already Alice running and the timer is nowhere. I know your pain, you don't have to be scared. The dreams are very pure, lay the written and focus. Keep that pen and paper, they will take you to that day. In the meantime, stand up, heavy.
By now we understand that millions of our compounds around us are made up of atoms of just few elements. To further understand the structure and composition of these chemical substances in terms of atoms, chemical formulas is a good start. In chemical formulas, we're gonna understand the difference between molecular and ionic substances. Once we understand those, we are right on course to name simple compounds, which we will discuss more in the following session, which is not today. So let's get to it. So we're doing chemical formulas. I want you to consider aluminium oxide. This is a chemical name. Now, if this is a chemical name, it actually means, or what you would know is that aluminium oxide consists of oxygen and aluminium. Obvious. But now you do not know the proportions in which oxygen and aluminium are in aluminium oxide. So for you to know how much of oxygen and aluminium is there in aluminium oxide, you're gonna need a representation of your atoms in terms of numerical subscripts. So in aluminium oxide, you're gonna have something of this nature. Now, this is a chemical formula. So a chemical formula is a notation of these atoms with numerical subscripts. So it means the ratio of aluminium to oxygen is 2:3 for aluminium oxide. So a chemical formula is actually that notation where you have your numerical subscripts of the atoms in a compound. Now, if you have, let's say, sodium chloride doesn't have the subscripts. So when there are subscripts, you assume that when there are no subscripts, you assume that the ratio is 1:1 for sodium chloride. So when there's nothing written, it means you have one of an atom. But when you are given, like in aluminium, it means you have two. Now there are two principal classifications of chemical formulas, which will be your molecular substances and your ionic substances. As you would guess, we'll try and break them down. So let's go to molecular substances. Molecular substances. Now, most of the compounds that we find around us are molecular substances, and you find that most molecular substances are your nonmetals bonded to your non-metals. And your molecule would be a group of atoms bonded together by attractive forces. So those are your molecular substances, group of atoms bonded together by attractive forces. Now, for you to understand molecular substances, or let's put it like this, in molecular substances, as we said, it's non-metal bonded to non-metal. You find that they are not just put together randomly. If you're talking of water, you would be taking of H2O. Maybe if you're talking of ammonia, you'll be talking of ammonia like this. If you're talking of carbon dioxide, you're talking of carbon dioxide, something like this. So there is a way that the bonds form. You can't just write your molecules in any manner that you want to write them in. So you would call these types of bonding, you would call these your structural formula. So in your structural formula, each bond is shown by these lines. So when they ask of a structural formula, it means that there must be lines that are shown. But as you go, you'd find that you write H2O like this, or you write ammonia like this, or you write carbon dioxide like this. Then these ones will be your condensed formulas, where you show your molecules without these lines that show bonds. So that is your condensed formulas. And your molecular formulas usually help to understand polymers. Now, polymers are formed from what is called monomers. Now, a monomer would be a molecule that bonds with another molecule to form a long chain of molecules. When there are long chains of molecules, you can say those are polymers. Now, polymers, you can take, let's say, paper clips and put them together to form those chains. That is a clear example of how polymers show. So that is your molecular substances, non-metal versus non-metal. You have structural formulas and condensed formulas. There are also spatial formulas that can be shown via a computer, or models that scientists do just to show how these bonds form in space. So that is your molecular substances. Let's move to ionic substances. These are formed by anions and cations, or anions and cations are what is called ions. So what are ions? Ions are charged atoms. What do we mean by charged atoms? Either an element or an atom will lose an electron to become positively charged, or an atom would gain an electron to become negatively charged. So when it loses an electron to become positively charged, it is called a cation. Then when it gains an electron, it becomes an anion. Now cations and anions, they form what is called your ionic compounds or ionic substances. Then your ionic substances are usually formed from your metals bonding with non-metals. You will have, let's say, you'll have magnesium. Magnesium usually loses 2 electrons. And then you have, let's say, chlorine usually gains an electron. Now, when you form a chemical formula for ionic substances, the main aim is for these charges to cancel each other out. Let's say if this is 2 plus, this has to be 2 minus, and then once they cancel each other out, they form a neutral substance. So if this is 2 plus, when you add this -1, you should get a 0. So if this is 2, you should multiply this by 2, then you get a 0. So you're gonna have magnesium chloride. So you're gonna need 2 chlorine atoms for you to bond with magnesium to form magnesium chloride. So that is how ionic compounds are formed. If you check sodium and chloride in chlorine, sodium is 1 plus, chlorine is 1 minus, so you will have sodium chloride. The same would go. Also, some ions, since we're talking about cations and anions, also some ions, you find that they are polyatomic. Polyatomic means there is more than one atom which forms an ion. For an example, you will have SO4 2 minus. This one is your sulfate ion. Or sometimes you're gonna have NH4 plus. So this one is your ammonium ion. So let's say I have iron 2 plus, and let's say this is iron 3 plus, and so SO4 2 minus. So these need to cancel each other out. So if this is 2 and then if this is 3, this is 2. For them to cancel each other out, we're going to have to multiply this by 2 to give us 6 plus, multiply this by 3 to give us 6 minus, and then it gives us 0. So ion would be Fe2 and then sulfate. Now this we have to put it in a bracket because it is an ion. Then you have something of that nature. So that is how you find your ionic compounds from your anions and cations. I think that is where we would want to stop for this lesson. Thank you from this side. Okay, I hope you have gotten the gist of what we are trying to talk about. Just if there's anything I can add there. Molecular substances, there's a non-metal and a non-metal. Ionic substances, there's a metal and a non-metal. So that is the general overview of molecular and ionic substances. As we go, we will understand them further. So for now, we will stop there. Thank you very much for watching. This has been Basic Chem 101 with SIHLE BONANI. My name is SIHLE BONANI. Please stay home, stay safe, watch my videos, subscribe, comment, like or dislike. It is really up to you. I hope you watch these videos, and when we go back, you'll be well equipped to understanding your basic chemistry. My name is SIHLE BONANI. Thank you very much. Booyaka!